Okay, so as a review, some people may or may not remember. Okay. How do you get to the Science Channel? Okay, you go to the school's website. Then what? Staff.
High school and high school.
Okay. If it will load up. Okay. Then you find that picture. Then, I know. I get it. Then you do what? Find the week, correct? Like for instance, it doesn't matter which week you click into, but like last week, assign worksheet 2, due 8/31. So some of you have it done. 31st is tomorrow. And of course, once you're here is your link to the Science Channel. Of course, we remember that, correct?
Yes, sir.
How many people might not have used it? How many of you think you might use it? Okay, well, and maybe you don't know yet. Okay? All right. So when we look at, this is maybe looking forward just a little bit. This is what next chapter is over, about forces. But yet there is still velocities that occur with forces.
Wait, what are we in right now? Physical science?
Yes. Just out of curiosity, what did you think?
What?
Just out of curiosity, what class did you think we were in?
English. I don't know what you call it. Human and is that due today?
Okay. Thank you. All right. So when we look at this, what does this remind you of? Going towards each other is still opposite directions because one is traveling east, the other one is traveling west. Those are opposite directions. If you collide with one another, what might be left over from last week? What did we talk about last week?
The Rams?
Yes, what about the Rams?
They use their horns and they just speared each other.
Well, yes, the leftover momentum. That's called conservation of momentum, okay? In other words,
Tell them to quiet down out there.
yeah. Okay, it's when you have two different momentums and when they're going in opposite directions or towards each other, then what you can do is subtract what's left over. You can write these down. You can just get this from, I'm recording this now. So if you just want to do this at home, that's fine too. Or you can write it out like that. Either way is fine. So, how do you find conservation of momentum? Well, you have to find two different momentums, and to solve for momentum first, what do? Mass times final velocity. One's going one direction, the other one's going in an opposite direction, and once they collide, it's what's left over. And if their conservation of momentum is 0, well then that force is balanced. Then there's no movement one way or the other. Okay? But if it's unbalanced, then you get your conservation of momentum. And that's why this is discussed in this chapter. We talk about forces, many different types. That is next semester. Next semester. Next chapter. That's what I meant to say. Okay. All right.
What are the chances I get this fly?
Okay.
Go ahead.
Does everyone have this content that wants it? Okay. Then finally, this is it, because next slide there's nothing. But
We need the inertia.
all right. So this is, as you can see, the first law. There are three. We get to the last two laws next chapter, okay? Because the second law deals with forces. The first one is just dealing with that of, as you can see, inertia. In other words, a lot of this is tailored towards, let's say, changing directions, okay? It's not that easy to do, okay? So is it easier for bigger people or smaller people to change directions?
Smaller.
Probably smaller ones, okay? Just because there isn't quite as much force of that mass moving in one direction, okay? Otherwise, how many of you, I'm sure a lot of you have seen the movie Cars, Disney's Cars. Has anyone ever seen the movie Cars? Okay. The secret, well, this is just in the movie, the secret to turning left on the racetrack, you got to turn right to go left. Okay? And that's what happens around a racetrack, because what you see happening with this inertia, tendency for any object to resist any change in motion. So as that car is moving at a certain pace, okay, if you do not change or turn your wheels to the right, okay, you're not going to correct that swerve. Okay? And that's why once the tail end of the car has finally straightened itself out, then you turn your wheels back the other direction. So what's happening, yes, you turn your wheels to the right, you correct that skid, and then move around in the other direction. You got to turn right to go left. I thought maybe that would be a good analogy for you people who have seen the movie. Okay? All right? Yes, you have to turn your wheels to the right to go left because of inertia. Okay?
Well, how come, like, when you're driving in the winter and you step on your gas, you don't go very fast?
It's because of the friction. There is none. That's what keeps your vehicle on the road. I'm guessing you're talking about having ice on the road, correct? Yeah. So what happens is, again, that's what keeps your vehicle on the road, the friction between the tires and the asphalt surface. And then when there is none, that's why you don't go anywhere. Okay? And with the invention of anti-lock brakes, that's probably saved a lot of vehicles from different types of accidents. It is human nature, and you may find yourself still doing this. I sometimes have to tell myself, okay, be careful when you're coming up to a stop sign. You don't, in the winter time, you don't just, I wouldn't say slam on your brakes, but press the pedal down to go around a curve, because what happens when you have the brakes stop on the front tires, but you're going around a slippery surface? If those wheels aren't turning, you're just going to keep skidding left, okay, because you lose all that capability of steering when those wheels are locked up. That's why they call them anti-lock brakes. So it happens even though you have your foot on the pedal. That's why you feel it jerking on there, because what it's doing is those brakes are grabbing and releasing, grabbing, releasing, grabbing and releasing. So those front tires are still turning, so you actually have a little bit of control on the vehicle. Okay? So then hopefully if you're going slow enough, you have your brakes on, you just let go, those front tires will start spinning again, and hopefully you regain control. Best thing to do is just not be going that fast to begin with. That's probably the best piece of advice.
How do you turn off your anti-lock brake?
I don't think you can.
I think you can take it. Or maybe
You might, but
turn your traction control off.
okay. But anyway, that's all I have for today. Then tomorrow I have something else for you to work on. We're going to review on Wednesday, and I can't stress this enough. The points on your paper, 4 points per problem. Okay? Those points start to increase as these evaluations go. We're up to about 7 points apiece on Thursday, and then 10 points apiece on your evaluation for your exam.
So if there's 7 questions, it's 70 points.
Well, yes. So what happens is if I don't show my work, I get the answer wrong, what do you know? That's minus 10 right there. I don't show my work, or excuse me, I show my work, I got the wrong answer, it's minus 4 then. I think you agree that's a lot better than minus 10. I'm no mathematician, but I do believe that math tells me that minus 4 is better than minus 10.
On this one, you just had to fill out your notes, you guys show your work.
Yep. Now, some of you people may have said, well, I do that on a separate sheet of paper. Well, we give you plenty of room, okay? Just please put it on the paper that is given to you. Okay, that's all I have. Catch up to you next time.